Hi everyone. Today I'm gonna talk about section 3.1, Math 180, Business Calculus. This section gonna talk about the first derivative and behavior of the function. Okay. Um, we did take we did know how to take the first derivative, but we don't know that what we're gonna what the first derivative helps you to do. In this section, you know that the first derivative will determine the increasing and decreasing behavior of the function. Okay, so suppose that f(x) is continuous, differentiable function defined on interval a b. Okay, then if you have the first derivative greater than 0, on every value of x in a to b, then fx is increasing. So what does that mean? I'm gonna, in shortcut, I'm gonna say if f derivative x greater than 0, then that's gonna give me fx increasing. Fx is increasing. Okay. Conversely, you have fx, f derivative of x is less than 0, then f of x will be decreasing. Okay. Or in another way, you can say like fx is increasing, then you can know that the first derivative of fx has to be greater than 0. And fx is decreasing, then you can say that f derivative of x is less than 0. Okay. What about in the case that we have f derivative of x equals 0? Then I'm gonna say fx is not changing, it's not increasing, it's neither increasing nor decreasing. So I say fx is neither. Okay. So now I would like to to remind you about some case that the derivative will be undefined. So you did learn in section I think 2.3, I think, or yes, there's one section in previous that I did to tell you about the cases that the derivative will be undefined. The first case is when fx is not continuous at x equal to a. So this will not giving you the derivative, okay, at a, okay, because there's no tension here, so there's no derivative. Okay, the second case is if the vertical, if the graph have like curves. So since it has a curves, then you will have like you don't want to have the you want to have the vertical lines at the tangent, but that means what? That means it's become undefined slope. So so in this case, we don't want to have the derivative. Okay, and the last case is fx has a corner at x equals to a, right? So so in this case, there is no unique tangent line, right? It's like an infinity tangent line. You can have many tangent line for at point A. So in this case, you don't have derivative also. Okay. Now let me talk about the critical values of function. If a function f(x) is defined at x equals c, and if either f derivative c equals 0 or f derivative c is undefined, then the number c is called critical value. Okay, so so you need to know that first thing you need to have f(x) defined at x to c, and then either this f derivative c equals 0 or f derivative c is undefined, then c is called critical value. Okay. So I would love to do an example here. So example 1, if I say find if any exists the critical value of the function fx equal to x plus 1. In this case, because this is polynomial function, so domain of fx has to be all real number, right? So all real number. And since it's all real number, then any value of x will make the fx defined. Okay, so I don't have to worry about the defined fx defined case. Okay, now I'm gonna just take the derivative of f derivative x and see, and I see that the f derivative of x equal to 1, right? You see that when you take the derivative of fx, you see that x derivative of x going to be equal to 1, derivative of 1 equal to 0. So then you will conclude that in this case, is there any value of x that makes f derivative of x equals 0? There's no value that make x no value of x that make f derivative of x equals 0. So there's no critical value in this example. I would like to have some more example. Let me see. Let's say okay, x4 minus 8x squared. Okay, let's do this problem. So example 2. 5 so this should be x over 4 minus 8x squared. Okay, so again, this is a polynomial. Function. So domain of fx is all real number. Okay, all real number. Now I would like to find the derivative of x and see. F derivative of x. Okay, so because f(x) equals to x4 minus x squared, so f equal x will be equal to 4x power lower than 1, so 3, right? And then minus 8 times 2 is 16 x. Okay. Now, you will have to make f dv of x equals 0 in order to find the critical value. See that? Either f dv of c equals 0. Okay, so you need to make f dv of x equals to 0, and then we're gonna find I'm gonna solve x to find the critical value, right? So let solve. So I have 4x cubed minus 16x equal to 0. So in this case, you need to factor, okay? You need to think right away about, can you factor something in here? Yes. You see that both the terms have a common factor as 4x. And when you factor 4x out, you're going to have x squared for the first term minus for the 4 of the second term, and equals 0. Okay, now you're going to apply the 0 factor probability. That's going to give you 4x equals 0, or x squared minus 4 equal 0. So either of them has to be equal 0 to get a solution, right? Okay. So now first case for x equals 0, you're gonna have x equals 0. Right. Second case, you're gonna add both side by 4. You're gonna have x squared equal to 4. And in this case, you can have answer as x equal to 0, or x, you're going to square root both hand side, right? Square root both hand side. Let me check this. So square root x square to 4, square root 4. Okay. So now you're gonna have x equal to 0, or x equal to positive 2, or x equal to negative 2, right? So this is square root over t. Okay. Now you have totally 3 this value, and all of these values are defined for Fx. So okay. We know that 0, x equals to 0, 2, negative 2, all defined. Okay. Are valid value to make Fx defined. Okay. So x equals 0, x equals to 2, and or x equal to -2 are critical value. And this is going to be the answer. You may also think about the case that is there any value that makes f of c is undefined? Okay, but in the because because the derivative of x is like a polynomial polynomial function, so you don't gonna have undefined case. So I'm gonna say polynomial polynomial. So there is no undefined f derivative x. Okay, so we have just done, for example, number 2 here. Let me have another example. Let me see if I have a good one down here for you. Maybe this one is good. Let me see. So there's no one here. Okay, I'm gonna choose this one. Okay. So example 3. I want to find if there is access the critical value for the function f(x) equal to 1 over x plus 7. Okay. So first thing I noticed that f(x) in here is undefined at where? F(x) is undefined at x equal to -7, right? Because f(x) is a rational function, so the bottom cannot be equal to 0, right? So so I would love to say domain is equal to x such as x is not equal to 0. X not equal to 0. X can be anything else except 0, right? So not equal to 0. And x can be anything else. Or I'm gonna say x can let me see. X is all real number except 0. Okay, so okay. Okay, so now now I would like to find the f(d) of x. I see the reason. Let me change the Same fun. Okay. And f derivative of x in this case. In order to find the derivative of x, I need to change the fx become because in here fx have constant in the numerator. So I'm gonna change it to become like a general power rule. Okay, so I'm gonna have like x plus 7 to power -1. Okay, so you will have what? F derivative of x will be equal to x plus 7 to power -1, and then derivative of that, right? You take derivative of this. Okay, so this is the general power rule. We applied chain rule for the power. So in this case, you need to first put the -1 or in front of the put down the -1 in front of the x plus 7 to power -1 minus 1. Right? I'm going to lower down 1, right? And I had to multiply with the inside derivative, right? That was outside derivative. So x plus 7 derivative. And if you still like like to do by the aside work with let use is inside function is x plus 7, right? Then you have u prime is equal to 1, right? And outside function is going to be f of u, which is u to power -1 equal to so then f derivative of u will be equal to -1 times u to power -2. And if simplify, it's going to be -u to 2. Okay, and that is outside derivative. We give you like f derivative of x equal to negative of u now become x plus 7 to power -2 time with u prime, which is 1, right? Same thing, but I just try to apply that in a quick way. So now I'm gonna have f derivative of x equal to negative x plus 7 to power -2, and that should be the f derivative of x. Okay, so what we are doing, we have find the critical value, right? I will change this become the form of the fraction. Okay, so let me rewrite it as f derivative of x equal to 1 over x plus 7 to power 2, right? And then I had to solve for f derivative of x equals 0 in order to find the critical value. So let's solve it, right? So I have -1 over x plus 7 square equals 0. And as you know that there is no way to have this fraction become 0 if the numerator is a constant number. So there is no way to make this equal 0. I'm gonna say I'm gonna have one more step. So move out here. Okay, I'm gonna say I'm gonna let the in order to solve for a rational equation, I'm gonna just let the top the numerator equal to the 0, right? So you see that -1 equals 0, no solution. There's no solution that make f divided by x equals 0. Okay. So this case, you don't have solution to get f divided by x equals 0. But you may have to think about the case that f divided by x undefined, right? So you also have to think about f divided by c is undefined. If then maybe you're gonna have a critical value. Okay. So you noted that because f derivative of x equals to -1 over x plus 7 squared, and this is a rational function, right? Since it's rational function, then it will be undefined if the denominator equals 0, right? So so it is undefined at when the bottom equals 0, right? X plus 7 equals 0. I say even square equals 0. That means what? X equals to -7. So maybe this guy x equal to -7 is a critical value. Okay, but you have to know that. But x equals to -7 is invalid value, or is a value that make f(x), the original function, undefined, right? So you cannot use this value as a critical value, right? So x equal to -7 is not a critical value. Okay, so the answer for this question is going to be there is no critical value for this column. Okay. Okay, so now let's move down here. By the way, I did talk about is f divided by x is greater than 0, then fx is increasing, and f of x less than 0, then fi is decreasing. Okay, so let's see. Down here I have some other problem. Okay, so this is the produce for constructing a sign chart for f divided by x. Okay, for all the critical value of fx, that is find all values of x for which either f divided by x equals 0 or f divided by x undefined. Okay, so you have to consider to this case if f divided by x is a fraction, f divided by x will be 0 only when the numerator equal to 0. Okay, so this is a thing that I did talk in the previous example, and it will be undefined only when the denominator equals to 0. Okay, so this actually helpful for you when you see a fraction or the rational function. Okay, so draw a number line and place point at the critical value. So number line and place point at the critical value. Okay, so say here is A, B is our critical value, and the points divide the line into open intervals upon which function increase or decrease. So this will determine which part will be increased or decreased or something like that, right? So I say this one, this one, this one, something like that, right? In each interval, choose a test number A, determine the sign of f divided by x at x equals to A. Then for case number 1, f divided by A greater than 0, then f divided by x greater than 0. Okay. It will be all the interval in that in that test point increasing. Okay. As in another case, that's f divided by A less than 0, then all the f divided by x gonna be less than 0 at that interval, and also the x gonna be decreasing on that interval. So let's do example 2 in the textbook. Okay. Let's say find the interval on which fx equals to x squared minus 4x is increasing, and the interval upon which is decreasing. Okay. So step number 1, find critical values. And in order to do that, you need to find the f divided of x. So which is 2x minus 4 in this case. Okay. And you need to know that domain in here is all real number. Domain of the fx gonna be all real numbers. I should write up here that better. And then f of x will be equal to 0 when 2x minus 4 equals 0. And then I'm gonna have x equal to as the is a critical point. Okay. So now you're gonna draw the number line. Okay, let me draw number 9. And you start from negative infinity to and then to the positive infinity, and you will place the critical values into on the number 9 here, right? Okay. And is there any undefined value of x in here? No. So you don't have to worry about undefined. You just put the critical value in here. So critical in here is 2. I'm gonna put 2 up here. Okay. And I'm gonna and what I'm gonna do? Let's say I'm gonna in each interval I'm gonna choose a test value, right? So I put test value here. Each interval, right? From negative infinity to 2, I'm gonna choose a number, a value, a number that's inside of the interval. So I'm gonna choose the easiest one, which is 0. And from 2 to positive infinity, I'm gonna choose another number which gonna be 3. Okay. So so in this case, what happened with the f divided by x? I'm gonna put here, right? I just care about if f divided by x greater than, positive or negative. That's all. I don't need to have like specifics. Okay. I know that at x equal to 2, f divided by x has to be equal to 0, right? So I should put f divided by x 0 in here. In that case, the fx will not change. It's just neither increasing or decreasing. Okay, so for x equals 0, I have a sidewalk. I have f divided of 0 will be what? 2 times 0 is 0 minus 4. So which is negative 4, right? So that is less than 0, which is negative, right? So I'm gonna clean this up to make more space. Maybe I'm gonna put down up here. So I have f derivative of 0 equal to -4. And then f derivative of 3 equal to what? 2 times 3 minus 4, right? 2 times 3 minus 4, which equal to 6 minus 4 equal to 2. So that is positive, right? So I did have, I know that from negative infinity to 2, okay, f derivative of x will be negative. So that's give me the second case here. And I also gonna know that, I'm gonna know that fx had to be decreasing on this interval. So I say fx here is decreasing. So I say decreasing. Okay, but I later from now I actually gonna just use the notation as an arrow going down. Okay, and from 2 to positive infinity, I know that f derivative of x is positive, then I'm gonna have fx is increasing, and I will from now I also gonna use the notation as an arrow going up. So the conclusion for this gonna be fx is decreasing on on negative infinity to 2, and fx is increasing on 2 to positive infinity. So let me see if I think I'm gonna stop now for the part 1. I'm gonna talk more in the next part for next week. So remember to do assignment 3.1 for week is due on Thursday this week. And I'm gonna see you. I'm gonna see you next week for part 2. See you later.